off with some of the introductions to our Nona Talk LIMS during fall of 2022, where we're going to be discussing a little bit of the requirements around LIMS, what makes it good, what makes it bad, some of the headaches that people have had in the past. Unfortunately, we did lose some of our panelists last Bible, where they had an emergency happen with their team, and they will probably join us for our next Nona Talk. The next Nona Talk is going to be Nona Talk Bioinformatics. Similar to LIMS, but it's a little bit deeper on the science side, where my expertise came in from LIMS. That's why we're starting off here. For our first panelist, I'd like to welcome Elizabeth Morrow. They have been a project manager for years. They previously worked at Boston University with the CIDR Lab, where they helped out with some of the COVID LIMS creation that they had for the university so that go about and have a way to test students. It was a real hard during the pandemic to be able to make sure all students were healthy and safe. And then they pivoted over to lattice automation a couple years ago, and the sole product manager helping engineers to get funded and create new open source tools for biology. As lattice automation, that is what they do. They create open source synthetic biology tools. Now, Dr. William Hart is also joining us. I really appreciate his attendance. He has a lot of experience in biology and has gone about to essentially be CTO at a variety of companies, and his next venture is going to be in making LIMS. So hopefully he gets a lot of value from this, and we can all work with each other to make this a success. I've seen in the past, that hopefully you've all seen a little bit, that everybody makes their own LIMS. There's a lot of LIMS vendor lock-in after you create it, and it's almost like we're all reinventing the wheel. I think that there could be some bare bones that we could all reutilize in some certain workflows and certain integration cases that almost all LIMS systems have. If you're not too familiar with LIMS, in my perspective, and a lot of people say that there's about 8 different integrations you're going to have. There's going to be workflows, workflow planning and execution tools. There's going to be data infrastructure management, some actual instrument interfacing tools like automation, lab automation. There's going to be some sort of data analytics, so you can come back and look at all the samples and see where things are going right or where they're going wrong, along with some compliance management. If you want to make sure you have quality systems in place, make sure that you're not sending out false positives or false negatives, along with the thought of collaboration with other systems so that you're taking orders from other LIMS, or if you need to transfer samples, or even just taking a patient-initiated order. And lastly, I thought behind patients is actually maybe going around with electric health records and EMRs or EHRs, where you, at the end of the day, want to make sure that all patient data is managed in a HIPAA-compliant manner. Similarly, some of these workflow benefits of LIMS. If you haven't been sold on LIMS, I'm sure you are because you're already here, then you know that LIMS is going to help you track your samples and make sure that you know where they're located. It's going to help you with reagents and other consumable inventory. As you start to build upon it, you'll start to actually be able to project your headway and say, oh, we need to order extra reagents in December. Lots of benefits from being able to manage it, but also those instrument integrations will help you go about in the future so that you can essentially go and not have so many scientists. You can click a button, not have that human error on one side or another. You have the thought of, with your workflow, that standard workflow where a person might be doing it manually. Once you have that instrument integration and also LIMS, you can really start to optimize because you're tracking how every single one of your runs goes. LIMS helps with configuration as well, where if you want to send off an email when your workflows are done, or a small configuration change, or if you want to add in a change of sample name or sample type, usually it's going to be configurable one way or another, along with modular. So as you get LIMS, maybe you want to tack something on a little bit extra, and that's some of those additional integration cases I was previously discussing, where Most LIMS systems that I've worked with have an accessioning application so that you enter samples into the system, where that accessioning might be part of LIMS, but it can be its own independent microservice. As I think about some of the last workflow benefits of LIMS, it's log report and dashboard generation, so the lab can see and know really quickly what needs to get worked on and what has to get worked on, and make sure nothing gets left out. And lastly, compliance. Like I previously mentioned, HIPAA compliance is one of the big ones, but there's a lot of different compliance, if it's financial or if it's more related to patients. LIMS can help you in one way or another to maintain and manage some of those data compliance requirements that the governments or multiple governments might have. So that's my little spiel about all the good things that LIMS has for integrations, or about some of the work benefits, and we'll chat about them throughout this next hour and a half or so. And as we get to them, if you have questions, please feel free to use the chat. I'll be moderating a little bit, but also since we lost some of our panelists with last file, I'll also be talking a little bit, as I've had 6 years of LIMS experience, but I consider today my last day as a LIMS engineer, as I'm going to go forward towards bioinformatics. So with that in mind, let's use all that knowledge I have. And let's use all the knowledge our panelists have and everybody here. If you have a thought, if you have a contribution, feel free, like I said, to throw it in the chat. So with my first question, we're going to keep it really open, really wide. And what are some of the critical challenges we faced in the past, or some of it could be patient information integration, or like I talked about LIMS lock-in before, sometimes getting it from the old schema to the new schema. I'll start off with Elizabeth, and then we'll move over to Dr. Hart.
Yeah, happy. Good morning, everybody. And George, thank you so much for including me. So just to set the context a little bit, with my interaction with LIMS, it was actually a pretty unique use case. And so some of my feedback might be a little bit niche, but I do think that a lot of it is widely relevant. So as George mentioned, I was at BU, and we as in BU as an institution decided to stand up a COVID testing lab to support all campus and staff. And they developed some really clear requirements around testing multiple times a week for each student and staff member. So we had to stand this up really quickly. We had a really fixed budget, and we were designing and implementing the system alongside the lab concurrent. So it was a little hectic. And I think some of the critical challenges that we faced, which George mentioned in the introduction, were really around the different regulations. So the three that I wanted to mention this morning were we needed to take into account HIPAA requirements around patient information for staff, and then we needed to also include regulations for FERPA, which is a student-specific health set of health regulations. And then we were also needed to be a CLIA certified lab. So we were providing test results to people. And there were a number of requirements that this LIMS system and its performance needed to adhere to. So some of we had to discern and really boil down what all of the requirements were around those regulations. And we were really lucky to have experts come in rather quickly. And so a lot of what I'm going to talk about this morning is sort of team composition, not only the challenges of a LIMS system, but also what we found in supplementing a really robust team helped us to navigate some of those challenges. And that's sort of the first thing I want to call out is team composition in the way of having folks who are subject matter experts with some of these like really, really complex legal requirements and regulations. And yeah, I think I'll pause there. That was sort of the first the first set of real big challenges that I wanted to highlight with my particular LIMS experience.
All right, Elizabeth, a quick question about that is with your team composition, are you looking for specific, suppose, legal lawyers for that perspective, or are you looking for expert engineers, or what sort of talent were you looking for at the end of the day?
Yeah. So we, as we were standing up the lab, we had a number of folks in the university who knew how to deal with automation and the hardware and all of that. But we needed, one of the key positions that we needed to fill quickly was a CLIA lab director. And so this is someone with a very specific set of skills, and who really thoroughly understood all of the regulations around a CLIA lab certification. So there's tons of it on the science side. Then on the LIMS side, you also have to include a lot of documentation about how your software is behaving and maintaining chain of custody, delivering results the way they need to be delivered, all of that. So they weren't lawyers. It's more someone who has experience with that CLIA certification process, as it is a process. And so looping those folks in as quickly as possible, I think, is really critical to the success there.
Awesome. I appreciate
Yeah, I have a follow-up question. So when it comes to finding these subject matter experts, how do you determine whether someone is actually an expert? And a lot of the time you have people that maybe they've read all the regulations but don't have so much on hand practical experience, or sometimes you have people that do everything almost too much to the letter where actually it's not necessarily required. So how did you go about that?
Yeah, luckily I was not responsible for recruiting and hiring those folks, but I will say that to your point, I think there's something to be said for practical experience. So all the folks that we brought in, especially around our electronic health record systems for both students and staff members, is folks who have very practical experience doing this work prior. So I think the difficulty of that is, one, you have to find access to those people. And two, sometimes you're in the position where you have to take a risk with somebody who maybe has a little bit less hands-on experience, but maybe well-versed. So that's not a great answer, but I would say our team definitely focused more on practical hands-on experience prior to their work at BU.
Great. Yeah, that sort of ties up with what I was thinking.
Yeah.
Awesome. Have you had some challenges so far in trying to make a LIMS system, Dr. Hart, or what have some of the challenges you faced so far?
Yeah, so I've had to do this a few times, and one of it was in the context of building it as a system. So I did have to think about all of the high-level problems, and there are obviously a huge number. I mean, one of the main problems with LIMS is it's such a nebulous, vague, overloaded term, and includes all manner of things. It depends massively on what type of company you are, and what sort of research you're doing. Are you doing early stage research? Are you doing manufacturing? Are you doing whatever? You have to engage with healthcare and all these sorts of things. And so a big part of the challenge with existing tools is lack of extensibility. Almost every one of these pieces of software comes with its own set of assumptions baked in, and almost none of them have any way to properly extend beyond, at best, some sort of API that you can potentially use. But a lot of those are lacking in a lot of ways as well. So I would say being designed for extensibility from the ground up is something that's missing from a lot of existing tools. And then the other is in terms of what configurability you do have within these pieces of software. It's tricky to manage that configuration. So, if you set up different schema for all the different data structures and concepts that your organization has to deal with, there's typically not really a friendly way for testing out changes to schemas, or rolling things back, or any of these sorts of things, which from software engineering are kind of part of the course, and you would expect. So again, I think these convenience tools just don't really exist as far as I've seen so far. And then again, I mean, there's kind of more specifics around the lack of extensibility. So, one example was being not, most of these systems are not designed for high throughput. So if you're generating large amounts of data, usually you have to develop, either buy or develop some sort of third-party tool, and then create your own potentially flaky integration with whatever LIMS system you have. And again, if you have workflows, for example, so workflows within the research organization, if they are anything other than completely linear, then the workflow tools tend to break down. So as you can imagine, and I've looked at open source LIMS as well. They have their own sets of problems. Usually they're too specific, they've run out of and don't generalize well. Or, it's just hard to have the trust that they'll be supported and updated long term, which is critical if you're going to bake this into a core part of your organization. And then others, the skill sets that the labs that tend to build these things do not, unfortunately, make for nice user experience, which is pretty critical in terms of you want the LIMS to stay as much out of the way of the scientists' work as possible. So those are a few things. I could probably go on all day, but I think that'll do.
Oh, you touched on so many good things. I wonder, how specific is your experience in academic setting or academic institutions?
So I've worked with academic institutions. I've not built one specifically for them, but the product that I built at Opthea was what is actually still being used by a number of academic labs. They do tend to have quite different requirements, and even more so, they want the LIMS to just stay out of the way as much as possible, and any kind of process is seen as a bit of a and it's something I've seen. You've got these very dominant players like Benchling, for example. They started in an academic setting, and I think that's actually potentially a bit of a problem, because it means that a lot of their core assumptions came from the academic setting, and they don't necessarily hold up when you move into the commercial setting. And all the sort of things that you would want to do in a commercial setting have to be kind of jerry-rigged on to make them work in some way, and I think that's part of the problem.
Yeah, I find this. I think there's some really interesting tension there. In an academic institution, I think that there's two really important things. One is budget. The budget is not going to be high for a really robust SaaS solution, and so it doesn't make sense to go down that road. But also, what you pointed out is the use cases are so specific and so unique in academic institutions and academic labs. And it's sort of finding a balance between creating a tool that perhaps not widely available to the entire domain, so maybe just academic users, but something that can be robust but also tailored to the needs of that individual lab, while having strong software infrastructure. We want to see versioning, we want to see testing, we want to see deployment pipelines. All of that's really important. And just what you were saying, you don't want something that's going to be buggy and breaking. But where do you find that balance? Where do you find the money? Where do you find the community? I think those are all things that I feel really thirsty for in the academic space, but doesn't necessarily have a ton of traction.
Yeah, for sure. I mean, one major problem is the fact that a large component of the users of a LIMS in an academic setting are only planning to be there for a few years. Mm-hmm. Yes. If not all of them, and even the research associates and postgrads and things afterwards, they're not really planning to be there long term. Yep. And so this promotes very, I'm just going to make it work for this particular set of experiments. I don't really care how useful it is long term.
Right. Yeah, I agree.
Nice, a good thing to think about, and almost a good transition into our next question, which actually I've been thinking about what's the difference in academia and industry, but you all have went over that a little bit. I think that without time those topics, are there any different tools that we could have where I see LIMS as something that industry comes off a little bit later? After somebody has a scientific idea for bioinformatics, it's usually around that time you need some compliance or to show that you have compliance. And are there any first sort of tools that you think preface a LIMS system or could go about and be a good way of making a software in parallel to having your LIMS? I could see a variety of different software tools if I really wanted to stack it up from an accessioning tool. You could have a QC tool along with some of the other tools I mentioned at the very beginning. So are there any thoughts on that?
Well, just to start it off, we didn't have any applications in parallel, but one of the things that we did have to do as we were creating an automated lab, a high throughput automated lab, was to integrate with like our PCR machines, some other benchtop robots, and make sure that the chain of custody would maintain through all of this. And so that again was a sort of specialized set of skills that we needed to make sure was part of the team. And just like you pointed out, Dr. Hart, that this was a postdoc student who was creating scripts. Single point of failure. Luckily, they worked and they continued to work. But that can certainly be a challenge, and that happening in parallel to the larger system implementation.
Yeah, I think I just want to underscore the main point, which is it's actually about having the right skills in the team as opposed to the right. That's what we need to optimize for early on. If you have the right people, they'll either figure out what the right tools are or build the right tools if they don't exist.
Absolutely.
Definitely agree with you on that one. Where building a good, strong team will get you very far, especially in LIMS, where you start trying to get a little bit more complex workflows or huge monoliths that get broken out that become very difficult to dissect in the future if somebody wants to go about and say, hey, how does this LIMS system really work? Or if they need to migrate to a new one or rewrite the whole application. As we going to move over to our next set of topics of sorts, but we're going to pivot a little bit over from talking about LIMS, some of the hardships, to talking about a little bit of the data behind LIMS. If there's any questions, once again, throw them in the chat. We can answer any of the questions from the topics we chatted about. So from the data perspective, well, there's quite a bit that needs to get done where LIMS being able to communicate with the database should never be a challenge, but getting the actual schema of how you can relate a sample to a reagent and get that scientific knowledge over into technical knowledge as well. It's a huge issue and always trying to add in more info as your LIMS system starts to expand, or if you need to go about and have additional integrations. There's definitely different types of database models that people use. I don't know if there's really a standard, although there are certain terms I've heard across multiple systems, like having a lot, and a lot being a piece of almost I guess, an actual specimen or actual object in the lab. But I've heard people call them reagent lots because their first lots were reagents. And then later on, when they continue to build their system, they realize, well, not everything's a reagent lot because not everything's a reagent. So as you start to think about some of these database designs and some of the data issues, I think that making sure your LIMS is scalable is important. But have you thought about any standardization or standards that people have when they build these data models out?
So we I think I'm going to address the question, but maybe not as directly as perhaps Dr. Hartwell. But I think so. We had this really interesting challenge of in an academic space that doesn't usually do high throughput work, that we were doing a high throughput testing lab where we were going to process thousands of samples a day. And this was going to aggregate, and we were going to see it scale exponentially because more people were being added onto campus over the first several months. So it was overwhelming, and we very quickly saw performance issues. So we were using a hosted cloud-based solution, but something that we were working really closely with the development team of that particular application. So we had to work with them to scale, and it became where we were like emergently purchasing more server power, and that was difficult. And so I think, again, this is sort of a posthumous reflection. We didn't have folks on our team that were thinking about data and data performance, and I think that is a result of the needs of an academic institution largely. Like, we don't need to be thinking about that usually. So I think the sooner that can be part of the conversation, if you do intend to manage a ton of sample data, I would recommend starting that conversation earlier rather than later. Yeah, I think that was, I'm just looking at my notes. I think that was the one thing on data that I wanted to mention.
Nice. What about yourself, Dr. Hart?
Yeah, so, I mean, it's tricky. I think have a bit of empathy around in an academic setting. You're not going to have people with the sort of skills for scaling things you need to scale in an academic setting. So that's definitely tricky. Obviously, in a commercial setting, I would say that, again, my number one is you want someone with appropriate skills. And I think one place where a lot of people go wrong is that they think if they have some sort of no-code SaaS solution that they don't need to think about how well to model the data, but you are still modeling the data. It is still software engineering, and so you need software engineering skills to do it. It doesn't matter if you're not touching a single line of code. You're going to run into problems later on anyway. So aside from early software engineering, it comes to formats. It's quite tricky in the wider life sciences industry to do something like this, just because there's so much fragmentation. Even if we took a snapshot of all of the types of instrument and labware and everything right now, and managed to get standard formats and schemas for all of these sorts of things, in a year's time, there will be so it's a constantly moving target, which makes it really difficult. When you compare it against something like healthcare, most things about a patient and patient data and standardized tests, they don't change very quickly because they have to go through a very lengthy process to get approval for healthcare. And so you can have these more standard, for example, which is the interchange format for healthcare data. And in that case, you can build tools on that, and that's great. I'm not really sure what the answer is, other than making it easy to build new integrations and connections and data formats in general. I think, that there are probably some underlying primitives around, what you define as a sample or a specimen or a lot or a aliquot or whatever. I think there's probably some fairly fundamental concepts that you could come up with. How useful that would be, I'm not sure, because really that tends not to be where most of the complexity lies in my experience. So yeah, I don't know. It's a tricky thing, and aside from having good people, I'm not sure what the right answer is.
I really, just to sort of build off of that idea, I really like this sort of future utopian vision of like having our process and the software features and the development and iteration of those features that are serving any community to be defined by that community. That lag that you're sort of talking about of like, in a year's time, this might look really different. There's not something that's very long-term standardized in a lab setting. I would love to see those two things very closely paired. Our user community being able to work closely with the development ecosystem to keep those changes recent and to minimize the amount of lag that's being seen, so that it stays relevant. I think, just to put out that utopian community collaborative vision, I think would be really wonderful to help bridge this gap.
I definitely think.
I mean, I completely agree. Sorry, Karen.
No, it'd be great to have that community, and especially in the LIMS side of things, where a lot of times I feel like there's this barrier between the scientists and the developers.
Mm-hmm. Absolutely.
In which we could get through that barrier and just have people chatting with each other. Maybe we'd have an open source LIMS system. That's a great success. I've seen quite a few, from Vika to I know a GNU LIMS out there, and quite a few others like Aquarium. The thought is that they don't scale, as you said, where that scaling part is where sometimes it's an engineer with some big bucks out there that figures out how to make it scale, but hopefully we can find somebody out there in the open source to help out. Maybe it's going to be on our end from Nona Research, or maybe it'll be somebody else making open source like Lattice Automation or a variety of these open source, companies that deal with software and biotech. One of the thoughts around this, also a standard. Why don't we have a standard? Maybe there is something outside of this that we do. I've seen like SILA, the Standards in Lab Automation, SILA, where they start to do some of the lab automation standards, as there's so many machines out there, and trying to get each one of them to work or get them configured is pretty much a fool's errand, because there's just new ones coming out all the time. With that in thought, maybe there needs to be a LIMS standard out there, or maybe another sort of a nonprofit group who can make that standard and continue to build on it, where we have things like SBOL for doing some of the actual standards for graphics that get generated, and lots of other SBML, tons of standards groups, but I haven't seen one for LIMS, and it might be that we need to make one. Something I'll think about as we continue to chat about these data issues or data problems. That's one of the solutions I can think of, besides just the tale of going about and throwing a bunch of money at it.
Which is not always a great option.
No, you don't always have money to do that. Are there any things that you think that we could learn from other domains, non-bio domains, where sometimes I think a lot of where in industry, maybe we're talking about e-commerce. Usually a developer will meet out with the sales rep. There's not really a barrier between there. But if you think about other types of applications, there's usually not that barrier in communication. Might be just different vernaculars where we're talking about scientific terms versus talking about technology terms, and the presumptions behind it. But are there any things that the two of you or even our audience can think of?
So I thought a lot about this. And one of the things that came to mind was actually a application or a software company that I worked with early on in my career, that started out as an open source platform for grants management in the academic institutions. So this group is now, they've moved from an open source tool that was started at MIT to now a SaaS solution that encompasses a wide array of grants related. So anything from conflict of interest to IRB reviews, grant submission, budget tracking, all of that. And one of the things that I really admire about their approach to this was, and it took several iterations, but they spent a lot of time initially on a user group that would buy into those standards. So you're sort of talking about, like what standards are out there that we could latch on to. And they picked some in the grants management space, and they all said, we're going to adhere to this, and we want to collaboratively develop something that works for our handful of institutions, offers enough flexibility that we can all use it, but we really have a say about what the features are, how we're managing data, that. And they did that really successfully, and they built a really strong user community. It took a lot of time, but again, going back to sort of this utopian vision for LIMS and for our lab spaces, it was step with the user community. The features that they were building were articulated by users, they were tested by users, and the requirements were dictated by users. And I find that to be so empowering, and a great way to have users really caring about the outcome of the system. It's not that they're just going to stick Band-Aids on and sort of make it work like we've been talking about. They're really going to buy into the success of the platform. And I think that example from another domain, it really got me excited about what's the potential in lab spaces around this. Like, could we take a similar model here? And my feeling is, yes, we could. I would love to know what you all think.
Definitely.
Yeah, so I mean, there's a couple of things that makes me think about it. I think there's another parallel. There's a company called MedPlum which works in the healthcare domain for an EHR system, and they did this thing of tagging onto the standard format of FHIR and just building it around that, and then like instantly you've got a community that actually agrees with that and is willing to put back in towards that. In terms of having sort of this sort of core group of users that are kind of driving the vision of a LIMS, I think again we'd probably need to narrow it down a bit because LIMS is just so broad. So maybe you've got maybe around a specific ELN, for example, or sequence tools, or because I think that the challenge is finding what are the tools that everyone's having to rebuild over and over again. LIMS as a concept, technically yes, but the specifics are so different that it doesn't necessarily work that way. So I think that's probably where we'd need to start. Let's say, who's using this categories of tools? Okay, like everyone's using one of these, so let's start taking a standard.
Definitely.
I think that's a really smart approach.
I think that's a good transition into our last little segment too. Before I jump into there, I'll discuss one thought that I've seen be a successful open source tool is Shoop, SHUUP, but it's not in biotech. It's actually in e-commerce, where folks like Stripe and Square all use this multi-vendor software. Imagine it's almost like Amazon hosting a website for a bunch of vendors to sell to users, where every vendor doesn't have to make their own online store. And the way they haven't updated it for a couple years now because during the pandemic they found a new model where they could pretty much make profit by selling it off customized for other folks. Maybe there's a company out there, there are companies out there that do that with LIMS, but it's not based off this open source fundamental basis, where that fundamental basis is a Django application that you can install as a pip package. And then if you want to overwrite a page, you simply go about and make a file in that directory. Or if you want to go about and extend their functionality, they give you great documentation, great YouTube videos to go about and make it a success. So as we move into the last little segment of this discussion with our panelists, we're going to talk prioritizing some of these challenges and some of the approaches, where I heard throughout that 45 minutes or so that we have challenges sometimes in funding for academia, along with being buggy or unscalable systems as it might be underfunded and similar issue. But the integrations, especially where there's so many integrations and there's not really this standard for people to build upon. Where to find, I think, will be real successful at the end of the day. And the first thought is, do we have any real tractable or really easily maintainable solutions? And I think starting off with making a standard around these LIMS software is going to be easy. And I can take that as part of the Nona Research Foundation to go about and start to say what should a data schema at least have in basis. I think there are a large set of tools we could go with, but not necessarily rebuilding everything. I think there are certain things like side notes, which is an ELN, to go about and say, hey, maybe this is the basis that we start to integrate another software tool with. Or maybe it's going to be that there's a small sessioning tool that goes into SideNote, so you can just add in all your samples, and then SideNote can really start to just be there for notes. Sort of finding the right platform of tools, I think, that all integrate with each other and start to go about and make integration. I think you mentioned Dr. Hart, MedPlum. MedPlum is a great example of an open source LIMS-esque software where they kind of built on what was already there and said, oh, well, let's make this little tool, let's make this little tool, and what they needed to be compliant and teach people how to go about and install some of those small sub-applications. Yeah, I guess that is the question of, can we go about and tracking solutions? Right now we don't have funding, obviously, to go about and start making this, but that would be the eventual downstream, is that we can either set up that fundamental baseline that folks can draw from and say, oh, well, I know I need a LIMS application. At least this application starts me off with user authentication, authorization, and a page to add samples. Or maybe LIMS needs to be a little bit more focused on a workflow engine. Maybe it's something to say, oh, well, let's integrate this with Airflow, which is an open source workflow engine of sorts that does a lot more on the bioinformatics side. But if we can easily have this sample get a session and then say, oh, well, let's send this over to Airflow and see if the results were good or bad. It takes some coding in Airflow to say, hey, this is how I want my pipeline to be processed. But finding out that platform and starting to set up fundamentals is a challenge that is, I think we could talk about for hours, but that we don't have that much time. So what do you think is one of the higher requirements behind this? Or what's your number one requirement, I suppose, behind the LIMS system? What's that big challenge that we need to tackle?
To kick this off, I would say, so I'm coming at it from a project manager point of view, not from a software developer. So I suspect, Dr. Hart, you might have some more technical insight to this question. But I think the two big things that stick out to me are having shared knowledge bases for like-minded domain users. So I think, Dr. Hart, you pointed out a really good, academic institutions are sort of their own use case. And even in that, there's variability. So I think finding groups of folks who have some amount of consistency across would be helpful. And then I think those two things, shared knowledge bases and domain specific groups, in my mind, will serve one, getting to a where I have, even if it's open source, been stated individual group, we can move to that can be shared open source, but it's well documented. Well, I'm a risk averse kind of, so those two things are really important to me specifically. I think that if we have documentation and we have user and shared collaborative approach will allow us to solve problems more quickly and to have the experience of a wider community, I think, is always a benefit. Yeah, so I think that's what I have my eye on years. the software.
I've seen a lot of software packages just forget to set up the requirements and version those requirements, and somebody will come back 6 months or a year later, and that project will take hours to figure out, and you really won't be sure if it was still working as intended, along with that documentation, because if there isn't any documentation, I can click around and say, it looks like it's working, but you really don't know what's happening on the back end of it. It's led me to appreciate some of the academic open source tools that came out, because there's that publication that comes along with the tools, so you can understand a little bit more of the inner workings, but doesn't really beat having a good, well-written read the docs, along with maybe some YouTube tutorials or more that can get people to see what the application does. But
yeah, and I'll add too that like as an open source software company with Lattice, like this is something that we're even going back and reviewing for our open source code, like how good is our documentation and how well supported would somebody implementing this feel. And we that have engineers like trying to wade through things that are really unclear and deploy systems that seem like they would be really beneficial, but it's a real challenge to get through all of that because it's not well documented. So yeah, I think that seems like sort of a straightforward thing to focus on and align around. At least if we have access to people's tools and we know how to use them, at a minimum, we can be doing that.
Yeah, I mean, my answer is actually basically the same thing to a large extent, actually. Not in particular, or even particularly code quality, things like get deployed and all these things matter. But I think that the fundamental thing that's currently missing is having these user groups that actually care and are willing to put some time in over the long term, so that we can identify which tools are worth uplifting and investing time in, and what the standard problems are, standard use cases, all these sorts of things. And yeah, to build up a kind of shared knowledge. It's such a wide space. There's so many different tools for so many different use cases, and build a map of the problems to be solved. It's kind of impossible to figure out where you should start.
definitely.
George, it sounds like you have a lot of work cut out for you. I'm teasing.
Yeah, I'm going to do a lot more research, and all the viewers today should put all their issues right in our messages, so we can start to track solutions, whether it's a small issue or if it's having to rewrite your whole system, where that's never a fun time, but it comes and goes. I feel that usually around 2 to 3 years is when a lot of LIMS systems get antiquated, and it's almost time for either a major upgrade or a whole rewrite. And that's a whole nother problem or challenge I've seen, is why do we need to continue to rewrite or upgrade our applications? Well, it's a little bit of having to stay secure. It's a little bit of also making sure that you're meeting all your use cases. But if we had some sort of baseline that we could all just say, oh, well, they're doing all the updates that we need, and we can just pull the updates for that basis, it would save time across the board for everybody. That, I think it's the thought of our community right now. It's a little bit spread out. I posted this or tried to recruit from a few different Slack communities, from Bits and Bio to Race Against the Clock, along with DNA Deviants, to name a few, but also reached out to some Nona folks on our own email list. Do y'all think that there's a potential place in our community that we could improve upon? How can we get these folks to talk with each other, or how can we get everybody in the same room like we have this panel right now?
I couldn't unmute fast enough. I think it's being willing to start small, actually. I'll admit, like for me personally, I I'm always thinking like large, I'm thinking at the end already. You know, I'm thinking where we're in a conference room and there's tons of institutions and we're all talking. But I think in order to get there, it can be one or two groups of folks that are aligned with the vision, and proving that out. So I'm encouraged by even just Dr. Hart getting to meet you. I think this is the start of a really cool conversation. George, the work that you're doing around really putting some formation around Nona, as a place where we can assemble, as open source folks. And I think, yeah, that's really what I want to see more of.
Definitely. We've got to start small and build up somewhere, because at the end of the day, we all start off with one person having an idea.
Exactly.
And I've seen some success outside of our LIMS, but in bioinformatics, where there's the thought of having like biocapacity, there's Nextflow, and there's SnakeMake. These are all tools that I've seen multiple industrial cases just used, but it's also been used in academia. That kind of cross collaboration that everybody's using it because maybe there's not enough pipeline tools out there, but with that limit of these pipeline workflow runners, maybe that's the thought that there's such a limit that people just reuse it. If we have boundless LIMS systems out there, but they're all addressing a very specific case. What I like about biocapacity is that if you set up just sort of the main application, and everybody goes and installs their own little modules on top of biocapacity, almost like if you had extensions in Google Chrome, where you have your Chrome and you're like, oh, I want to install Otter, or I want to install some PDF viewer, whatever you need. And I think that might be a good track as well for future LIMS systems. It's almost similar to how MedPlum is doing it, but I want to make it so that there's a store for every integration out there. If that integration is, oh, I want to have a Hamilton work on here, or oh, I want a Tekin, or I want to export this over to Salesforce, or come about and use all those little edge cases that everybody's already doing, because I've seen 2 or 3 LIMS systems that get integrated into Salesforce, and at the end of the day, usually people hate that integration. So it might be a Salesforce thing, maybe it's just a LIMS thing, that is just not based enough in the lab. But that's all in mind. I think, you have any thoughts on that, Dr. Hart?
I was just going to say, I think that's exactly where we want to go, this being plugins and things. But I think it's just what Elizabeth was saying is to even know what that overarching thing is supposed to look like, we need to start off with a few specific cases, and then we'll be able to see what some of the patterns are across these seemingly unrelated cases, and then from that you can build this underlying structure that then you can just have as a generic plugin system.
Awesome. Definitely need some of these additional use cases. I don't think I have enough for academia, to be honest, because academics are on that cutting edge of things where they're trying to make the next bioinformatics pipeline or the next LIMS tool of sorts to help out in the world. Sometimes getting to know though that cutting edge technology is just outside of my reach until I talk to somebody in that academic institution. Do you think we can wrap this up a little bit early today? If there aren't any questions from our audience, but I wanted to thank everybody for joining us today, especially Elizabeth and Dr. Hart. Your insight was crucial for this, and being able to think about some of the hardships we face, from the application side to the data side, even the community, along with the actual solutions that we can go about, or the thought process that we're also in agreement about, things like having a LIMS system with plugins, but we're still kind of fuzzy on that underlying base, or having about and hosting small events like this for us all to talk with. We'll be uploading a video up to YouTube of this recording of the panel. There's going to be a transcription also for our panelists to go about. I want to thank the panelists so much. Really appreciate your insight. Want to thank all the audience as well. Really appreciate y'all coming in to see us listen to us and ask any questions that you had. Make sure if you want to reach out, feel free to reach out to me, george@nonasoftware.org. And if you want to reach out to our panelists, I'll make sure that I can forward you along their information as well. Thanks again. I hope you all have a wonderful day, a wonderful weekend, and go build some sort of software, do something for bio, and keep helping out the community. Until next time, y'all. Thank you.
Thank you so much, George. Bye, everybody.
Thanks very much. It's great to meet you.
Bye-bye.